Let's take a look in this section on the programs that we use. So, ProgReg and ProgGLM are a little different in the outlook, not very much, but they produce the same results. So we have our model statement where we say the outcome, log BMI, is a linear function of sex and then the age dummies. Mind you, if you have 7 dummies, only 6 are necessary, of course, because otherwise one is over-specified. The nice thing about GLM, unlike ProgReg, is you can say, okay, I leave the dummy coding actually to the procedure itself. Reg doesn't do that for you, but GLM is willing to do that for you. So you specify age 7, but you say, wait a minute, it's a class variable, and that's the sign for the procedure to translate this into 6 dummies in this case. Okay, good. You notice another difference. In the model statement in ProgReg, there is no /solution option because it by default produces regression parameters. GLM doesn't. It actually is an ANOVA-based procedure where what do we do in ANOVA? In analysis of variance, we look at variance components, degrees of freedom, tests, etc. But parameter estimation is not so important. But for us here, yes. So if we use ProgGLM and we want to do linear regression, we actually want the solution. We want the regression estimates, and that's why we need to include the solution option here. Okay. And then for the linear mixed model, we use the same model. So in ProgMixed, we use the same model statement, same class. It looks very much like GLM with only one exception. We now have the possibility to include also random effects. Where are they? Well, they haven't been specified yet. What I'm saying is, if you can specify the random effects, but you don't do it, it's still good old-fashioned linear regression. So, you can use ProgReg, ProgGLM, and ProgMixed, and they will all do the same or nearly the same thing. The one small difference here between the two versions, Model 3 and Model 4, so to speak, or Program 3 and Program 4, is in one case we use REML, restricted maximum likelihood, and in the other case we use full maximum likelihood. REML is a small sample bias correction procedure version of the estimation. And then finally, we can also use the survey reg procedure. But if we don't specify any of the design characteristics, survey reg is simply an ordinary reg, an ordinary regression. So what I'm doing is I'm using also the more complex procedures already, but without using the specific features of those procedures. So I'm basically fitting the same model in many different ways. Okay. Now, if we start from the PROC survey reg procedure that we just considered, we can now start adding the things that we really want. For example, is there a finite population? Okay, by total is equal to 10 million, for example, or whatever number applies. You can set this to the finite population value so that you use the sampling without replacement in finite population correction. If you would do the census finite population as I showed before, you can put the total equal to the sample size, basically saying that the 8,384 people you're using is not a sample coming from Belgium, it's the sample from a mini country that's equal to a population size of 8,384, and you have simply done a census. Stratification, no surprise, strata province. Clustering, no surprise, cluster HH for household, WFIN for weighting, etc. And if you throw all of those in together, you get a program at the bottom of this page here, where you have the class, the weight statement, stratification, and also the finite sample correction. Okay. For the linear mixed model, but now with inclusion of the random effects here, you include same program, random intercept, subject is HH, so that says, wait a minute, the data are not all independent, they're actually clustered within households. If you would go for a three-stage approach, it's perfectly possible to do that with ProcMixed. You would have a random town effect and a random household effect specified here at the bottom of the page.